Let's get into our objective 2 of our gases and kinetic molecular theory unit. First, we're going to review some key points that still play a big role in this objective. Remember, all molecules move, and the random movement of molecules is what produces pressure. The other big thing here is that when you heat a molecule, they move faster, so they spread out more, which causes them to expand and produce pressure. Like we said, if you leave a ball outside in the cold, the ball deflates because those molecules don't move so fast. And then if you heat them back up, the ball actually inflates a bit, like during the day. If you never noticed that, it's pretty interesting. What's the effect of adding gas? Well, when you blow up a balloon, you're adding gas molecules. The more molecules you put, the more pressure there is. If you look here, in picture 1, 2, and 3, she keeps adding more and more air molecules, and the pressure inside that balloon increases. So if we're going to understand gas, which this unit is about, you need to measure 4 different things. Pressure, we've talked about it. Increasing heat can increase pressure. Temperature, the faster you move the molecules, the more they spread out. The faster you heat the molecules, the more they spread out. Volume, remember, is how much space something takes, and the number of particles. So let's look at each of those quickly. Turn on the laser pointer. So if we're looking up at this slide up here with the red dot next to it, it says pressure and the number of molecules are directly related. In other words, the more molecules you have, the more they hit each other, and the more pressure there is. The less molecules you have, the less pressure there is. That's common sense in a way, if you think about it. If you put more molecules into a balloon, well, there's more pressure and it blows up more. If you double the number of molecules in a container, well, look, we start with 1 atm. We double that. We also double the pressure because now there's twice as many molecules. So that's what directly proportional or directly related means. The more molecules you add, the more pressure goes up. The opposite's true too. Let's start with a pressure of 4 atm. As you remove molecules from the container, the pressure decreases. In this instance, we must have removed half of the molecules because the pressure went from 4 to 2. If we remove another half, we're down to 1. Eventually, what happens is the pressure will equal the inside of the container and outside. Not that you need that for the test, but that is like diffusion. Another key component of gases and understanding them, we said, was temperature. And we've already said raising the temperature of a gas increases the pressure, as long as you hold the volume constant. In other words, if you have the same container and you increase the temperature, the pressure goes up and the molecules speed up, so they hit the walls harder. The only way to increase temperature if the pressure is the same, keeping the pressure the same, is to increase the volume. Meaning that if you do not change pressure, you manage pressure is the same, and temperature goes up, well, they need to spread out then, so the volume's got to increase since you're not letting pressure increase. And we look here, if you start with 1 liter of gas at a pressure of 300 K and heat it up to 600 K, there's only 2 options. We're heating it up. The molecules are going to move faster. So one option is the volume increases because they spread out more, the molecules do. Or the other option or possibility, if you keep the volume the same, is the pressure increases. In this case, you can see we fix the volume. We won't let it increase. Well, those molecules are moving faster and faster and hitting more, so the pressure increases. So if you increase temperature, either the volume or the pressure must increase, or some combination of the two. Practice questions. You can press pause after I ask the question to think of it, but of these 4 pictures, which flask would have the highest pressure if they have the same number of molecules in them? So if they all have the same number of molecules, then flask 1 would have the highest pressure because those molecules are squeezed into a smaller area. Flask 4 would have the highest. What about which of these flasks has the highest volume or biggest volume? Remember, volume is just space, so 4 has the biggest volume and 1 has the least. All right, already done with this objective. Make sure that your notes have these notes in them. All molecules move. The random movement of molecules produces pressure, and increasing temperature causes higher pressure because the molecules move and expand, and higher volume. And increasing volume with lower pressure because there's more space.